Lesson 14 is going to talk about some of the different number systems that are used in computer science. So first, we're going to start out talking about the decimal number system that you've been using your whole life and talk about some things that you probably know, but probably haven't thought about a whole lot. So for one, the decimal number system is base 10. Sometimes we call it base 10. And there are 10 digits in it. But even though there's 10 digits, there's no digit for the number 10. The digits start at 0 and go up to 9. So the first digit is the 0, the second digit is the 1, the 10th digit is the 9, and then to make the number 10, we have to start over again and do 110 and 0 ones. That's the way you've been doing it for your whole life. So if we consider a number like 5,402, there are five thousands. There's four hundreds, there's 0 tens, there's two ones. And so if we multiply each of those numbers, 2 plus 0 plus 4 plus 400 plus 5,000 makes 5,402. The other number systems work the same way. The binary system has two numbers in it. Those two numbers are 0 and 1. And so the first digit is always the number of ones, and then each digit is the number of whatever the base is to an additional power. So for the decimal system, we have 1, which is 10 to the 0. Then we have 10 to the first power, 10 to the second power, 10 to the third power, or 1,000. Same thing with the binary numbers. We have 2 to the 0th power, which is a 1. Then we have 2 to the first power, which is 2. The next digit is going to say the number of 2 squareds or 4s, and then the number of 8s. So if we had a number like in the binary system 1101, that would be 1 1, 0 2s, 1 4, 1 8. 1 plus 0 plus 4 plus 8 would make 13 in the decimal system. And when we write that out, sometimes we put the word bin after it. Sometimes we just put a B after it. And then other times we do another way that we're going to show in a couple minutes. And then another term you've heard is bits and bytes. So when we talk about how much memory there is in a computer, we talk about meg or we talk about gig, but those are megabytes or gigabytes. A byte is 8 pieces of memory, 8 zeros and ones. 8 bits makes 1 byte. If a computer had 256 megabytes of memory, that would be 256 million bytes, or 256 times a million times 8 bits. We have two other number systems that we use on occasion. The most common is the hex, or the 16-bit. Now there's 16 digits in that system, but since we only have 10 numbers, once we get to 9, we start using letters in alphabetical order to count for the next digits. So A stands for 10, B is 11, C is 12, D is 13, E is 14, F is 15. And then to get to a 16, just like in the other number systems, we start over. So we would do a 1 for the next digit and then a 0 for the ones digit. So 10 hex is the same as 16 in the decimal system. Here's another number, so 5C02. The 2 is going to be the number of ones. The 0 would be the number of 16s. The C would be the number of 16 squareds, or 256s. And then the 5 would be the number of 4,096s, or 16 to the third power. So 2 times 1 plus 0 times 16. C stands for 12, so 12 times 256, and 5 times 4,096 would add up to 23,554. You can see how we have a pretty big number here with only using 4 digits, so that's one of the advantages of the hex system. And the reason we are using everything has to be a power of 2 is because in the computer everything is either on or off. There's only two states, and so every number that we use has to be a power of 2 when we actually store it inside the computer. The octal system is an okay system, but it's not used very much because numbers are bigger in the octal system or use more digits than in the decimal system. In the hex system, it uses less digits, so it's more convenient to write things down. So I'm not going to talk too much about the octal system, but it works very similar to the binary and the hexadecimal. Right. One of the things I do want to talk about is how we write down. So I said that we put bin in front or in the back or hex or des. Another way that we do it is for a hex number, we'll put 0x and then the number. For a binary number, we'll put 0b and then the number. For our octal number, we just put a 0 because we don't want to put a 0 and then an O. That's kind of confusing. So if a number starts with 0, normally that would just be a number you would skip or forget about, but in computer science, that usually indicates that it is a octal number. So there's a couple different things that we can do. If we have an integer x and we want to change it to hexadecimal, we can use the integer dot to hex string, or we can use the integer dot to string and then x comma 16. So the x would say the number, the 16 would say the base. So let's go over to Eclipse and take a look at that. We'll start a new class for lesson 14 and turn on a main. And let's copy those couple things over that we just looked at. So we'll start out with x being 300901, and then we're going to print it out as a hex string and see what the computer does for us. So x is our integer, and we need to add a semicolon at the end so that statement will work. So if I just did system.out.println and I do a x, we can see that our number prints out as 300901 like we would expect. If I add in the to hex string and I print that out, FCD would be the hex string. Let's start out with some of smaller numbers like the ones that we talked about earlier. So suppose we start out with x equals 1. And we print that out, it's the same in decimal or hex. If we have a number like 9, it's the same in decimal or hex. But if I go to bigger numbers like the number 10, it prints an A because A is the symbol for hex 10. Or if I put an 11, it will print a B. If I try a 15, it will print an F. And then if I go one number bigger and try 16, it prints a 1, 0. This is the hex number, 1, 16, and 0 ones for that number. Looking at some of the other options we also have integer to binary string. So instead of to hex string, to binary string. So a number like 16 will be 16 in decimal. It'll be 1, 0 in hex. It'll be 1, 0, 0, 0, 0 in binary. So that's 0 1s, 0 2s, 0 4s, 0 8s, and 1 16. If you add that all up together, it is the number 16. Let's also look at this other version of it. We can do integer dot toString x comma 16 and just make sure that that works as well. So we want system.out.println, and we need to close our parentheses here. So let's take a look at that one. It should work the same as the hex string. So let's put those together. So we'll do our hex string, we'll do our toString with the x comma 16, then the binary will be the last one. So that works 16, 10, 10, and then the 10,000, or at least that's what it looks like. These two are hex, this one is binary. With binary, we could do the same thing as the .toString, but with a 2 for the base. So let's take a look at that. With a 2 for the base, right, it works the same as the 2 binary. So if you know the base, you can use this version, or you can use the 2 binary version. We can also do the same thing with octal. As you might guess, it says .2 octal, or you can put an 8 as the second number. So let's try both of those versions. To octal, or put an 8 for the second number. So 2 0 or 2 0, that means 0 ones, 2 8s. 2 8s are 16, so that's the same number as we had up here above. Let's see, and we could pick any base we wanted up to the number 36, since we could come up with 36 different characters. So we could also do this same thing with the 36 for the base, and that would go all the way up to the letter Z. So 16 here would be a G, because that's the next letter up. Right. Also in the list here is a version for you to do these kinds of things by hand. So if you want to go from decimal to binary, what you're going to do is continue to divide by 2 over and over and over again, and you're going to keep track of the remainder. So 147, if you divide it by 2, that's 73 with a remainder of 1. Divide it by 2, you get 36 with a remainder of 1. Divide that by 2, you get 18 with a remainder of 0. So you get, basically you keep track of the remainders, and then you read the number backwards. So the first digit is going to be the last remainder you got. So this, as a binary, would be 1 0 0 1 0 0 1 1, which is the exact same as the number 147. You can do the same thing with hex, but that's not normally considered the easiest way to convert to hex. Usually people that convert to hex will convert to binary first, and then they'll group things in 4 numbers when they're converting. All right, so that's what's talked about in the trick for converting binary to hex, right? The other topic we need to talk about is binary addition. So remember, when you add numbers together, you add in the columns, and then if a number is too big for a column, you carry a 1 into the next column. That works great for decimal. If you get up to 9, and you get 1 bigger, you get to 10, so you'd put a 0, you'd carry a 1. With binary, the biggest number you can get is a 1. So for example, if we wanted to add these two binary numbers, we're going to write them down one above each other. 1 plus 1 makes 2, but the way you write a 2 is you write a 1 and a 0. So you put the 0, you carry the 1. 1 plus 1 plus 1 is 3. Well, 3 is the same as 1, 1 in binary, so you put down the 1 in the 1 spot, and you carry the 1 that was in the 10 spot. 1 plus 0 plus 1 adds up to 2, which is written with the 0, carry the 1. 1 plus 0 is just 1. 1 plus 0 is 1. 1 plus 1 is 0, carry the 1, and then you put the 1 down. So if we add these two numbers together, you get 1 0 1 1 0 1 0. This first one was the number 51. The second was the number 39. If you add those together, you get 90. And if you convert this number, you would also get 90. So that works out. Let me know if you'd like to see some more examples of that.